Okay, the other thing you guys will be doing today is ionic bonding. Now, what we did yesterday in the lab really should be everything you need to know about ionic bonding. This should be more of a review, and then the last thing that I'm going to show you is an easier way to do it, a trick way to do it. So again, I'm still new with the program, so forgive me if anything goes a little wrong here. So let's start. Let me speed this up just a little bit. This is called ionic nomenclature. Nomenclature is just a fancy way for naming and writing formulas. Okay, so we're going to start with naming compounds. I'm going to give you a few examples here, and then I'm going to name them. The first one is calcium fluoride. The second one is magnesium oxide. And the third one is strontium nitride. After you guys get these examples written down, I want you to talk with the person next to you. And again, you should have already started to see this yesterday. And I want you to explain to them what always is written first, what always is written second, and how we name things. Okay, go ahead and pause the video now and do that. What you should have figured out is that the first thing that we do is we name our cation. You could say either we name the cation or we name the metal. Cations and metals are the same thing, and it's whichever makes the most sense to you to think about. The second thing we do is we name our anion. Again, you can say that we name our anion or we name our nonmetal. Make sure that you name your anion with an IDE ending. So you notice that instead of fluorine, it was fluoride. Instead of oxygen, it was oxide. Instead of nitrogen, it was nitride. Again, you saw that yesterday. Okay, the naming shouldn't be anything new. Now, ionic nomenclature does get harder, but not until after the quiz that you're going to take on Wednesday. Okay, on Wednesday, you're just going to be doing this basic stuff. So go ahead, why don't you guys just look at those two examples down there and tell the person next to you what their names are. Take 10 seconds to do that. You should have said that the first is aluminum phosphide, and you should have said that the second is sodium sulfide. Okay, so that's naming. Again, the naming is the easy part. Next part I'm going to have you do is writing formulas. Now, writing formulas are a little bit more complicated. Writing formulas is essentially what you did yesterday when you were doing the puzzle pieces and you were moving together the spikes in the puzzle pieces so that they were adding up to be neutral. Okay, so writing formulas with ionic compounds, we always have to keep them neutral. All right, and we saw that in what the earlier video that you watched with the Lewis dot diagrams, and again yesterday with the puzzle pieces. So I'll be saying over and over and over again in the next couple of days that ionic compounds must be neutral. It is essential for you to be able to do ionic bonding nomenclature to know the charges on the periodic table. Now again, I just drew a little one over there on the side. Remember that as we go across the groups, we're going to ignore our transition metals for today, and we're just looking at groups 1, 2, 3, 4, 5, and so on all the way to 8. You need to know that group 1A is plus 1, group 2A is plus 2, group 3A is plus 3, group 4A is plus or minus 4, group 5A is minus 3, group 6A is minus 2, group 7A is minus 1, and group 8A is 0 because it does not form ions. Pause recording now and explain to the person next to you why those charges are for those group numbers. Okay. Again, it's essential for you to know the charges of those main group elements in order to do ionic bonding nomenclature. Okay, if you do not have those charges down, you will not be able to write the formulas. Okay, writing formulas, again, our drive has to be that they are neutral. So I'm going to give you a few examples here. The first one is lithium and iodine. Lithium is a plus 1. Iodine is a minus 1. So I would need one of each of those to make a neutral compound, lithium iodide. Next one is aluminum and fluorine. Aluminum is a +3. Fluorine is a -1. So I need 3 fluorines to make a neutral compound with 1 aluminum. Okay, why don't you guys try this next one? Go ahead with the person next to you, tell them what compound this would make. You should see that since calcium is a 2+ and chlorine is a 1-, I would need 2 chlorines in order to make a neutral compound with the calcium 2+. So you can see that I did that here, and we have CaCl2. That's what you did yesterday in the lab. You figured out those formulas, but you saw that they got a little bit more complicated when you had 2 cations and 3 anions, or vice versa. So this is the reasoning way to do this. Half of you will always reason through them like this, and half of you will use what I show you next here, which is called the crisscross method. The crisscross method is just a trick on how to write formulas. What you do is you write your ions with their charge, and then you crisscross those charges. Now we know that when we write subscripts, those aren't actually charges, and that's why this is just a trick. So you're not actually crossing the charge, you're crossing the number that's associated with the charge. So I cross the 2 over with the fluorine, and I cross the 1 over to the magnesium, and my answer is MgF2. Again, see that the 2 came down here, the 1 came down here, and I ended with MgF2. Okay, here's another example. If I have aluminum with a 3+ and sulfur with a 2-, I crisscross the numbers, and I bring the 3 down near the S, the 2 down near the aluminum, and I end up with Al2S3. Okay, let me put out another example here. Why don't you guys try this one? We have sodium with a 1+, phosphorus with a 3-. Go ahead and figure out what compound that would make. You should have said Na3P. Now keep in mind that if you were doing these fine yesterday and the last thing that I just showed you, then you don't necessarily need to use the crisscross method. If you can reason through them fine, then you don't need to do this. One more example. If I have potassium, which is a 1+, oxygen, which is a 2-, I crisscross those and I get K2O. So you can see why it's essential that you have to know those charges on the periodic table in order to do these. Now remember I said that this is just a trick. So there is one place where you have to be careful. You have to be careful and remember that your subscripts need to be as reduced as possible. Okay, so if you get in a situation where they have to be reduced, make sure that you do that. So for example, think about just reasoning through it here. Tell the person next to you what compound Mg with a 2+ and O with a 2- would make. You should have said that since they are already neutral together, it's just a 1-to-1 ratio, MgO. Now what happens when I crisscross those is I get Mg2O2, which is fine. We just have to remember, if we're using our crisscross method, that we have to then simplify that and make it MgO. Okay, I'm running out of time on how long these videos can be, so I'm just going to show you the next page in total here. You can pause. Why don't you pause right now and try these ones. And then once you're ready, here are the answers. Okay, you guys can pause and discuss those as a group. Okay, and that's all I have for you today. I hope you guys have a great weekend, and go green.